So besides Kate, who was in the earlier talk on modernizing C++? Okay, decent number of people. This talk's going to hit on some of the similar topics, but with a slightly different slant. And I had a legacy in the original title. As I was working on this and putting in these photos, I decided that vintage might be a better term than legacy. So flight simulation, we pretty much do everything. If it's ever been in a cockpit, we've probably seen it. We've probably either simulated it, or emulated it. And there's some examples of what I look at on a day-to-day basis beyond just C++. And flight simulation actually has a long history with parallel programming. If you look back, say, 15, 17 years, you would have seen systems that had Motorola 68 or 88K processors in them. And the reason that those were used was because we tend to take a whole bunch of systems that are in an aircraft and try and bring them into one single computer. And so at that time, parallel processing was big. Over the years, we actually scaled back. As CPUs became more powerful, we were actually able to run everything that we used to run on 4 or 8 68Ks onto one x86-based system. And a few years ago, we ran into this particular beast. This would have been something that was quite large for us at the time. As it turns out now, this is probably a medium-based problem. And as we began to see things like this come along, we decided, our code base really needs to be updated so that we can take advantage of what's in C++ 11 and meet the needs of these type of problems as well as anything that may come along. So you notice there's a reference to PDP 11 there. Prior to working with 68Ks, we certainly did simulators on PDP 11s. We don't have any in stock anymore. We've since put in single-based computers that are doing emulations of PDP 11. Problems like from a PDP 11, a simulator probably has a lifeline of more than 15 years. And it's quite expensive to go in and take out a complete compute system as well as all of the I/O systems and replace them. So they're still out there. More people coming in. And I just went ahead and listed a bunch of the things that we've done to our code base. It's certainly not exhaustive. There were more things that we did to this code base. Yeah, so the developers that I work with, there's over 100 of them. Programming is certainly not their first and only job. So you can see there's a whole bunch of things that they probably talk about before ever talking about C++. And historically, they've probably been working in Fortran instead of C++. So it's a big change for them. And you're going to see in a number of slides here some very interesting things that they do with C or C++. And it's not just the people that I work with, it's vendors that we work with as well. Okay, I have a back-to-school teacher to thank for this title. I was probably the only person in the room that looked at it and said, wow, that's misspelled. And of course, if it's undefined behavior, then technically my kiddos could have turned in late homework and probably got it accepted instead of accepted. There is a talk tomorrow morning that's talking about the Joint Strike Fighter coding guidelines. They do not use exceptions in their code base. From a flight simulation standpoint, we're the consumer of whatever they might do on the JSF. We don't actually do the JFS, flight safety. But any other vendor working on an aircraft, anything that they do, we would be consuming that. And we wouldn't necessarily do exceptions except for the fact that we have a C++ framework that calls Fortran, that calls back to C++, that calls back to Fortran, that calls back to C++, and on and on. And again, that's the language of the developers. So checking return values, probably not number one on their list either. So we do actually handle exceptions in our code base. C17 Globemaster. I've been to Going Native, C++ and beyond, committee meetings, C++ now. There's always usually some sort of question about how can we start working on our code base to get to C++11. And I'm going to go through a bunch of different areas here that we at least looked at in some point, and you might have similar questions. The work that we started on was at least 2 years ago, and part of what we said was we've got some extremely large classes with very fat interfaces, and we said nobody's using half of these functions, so we can eliminate them. And that was one of our justifications. I said 15-year or more supportability on a simulator. Turns out most companies don't support compilers for that long anymore. So certainly we had tool chains that were no longer supported. It so happened that about 2 years ago, the compute platform that we were using happened to be obsolete as well. So we were actually in a phase where we could say we have to spend some time looking at hardware again, and we can actually make a change if we want to software. I mentioned our problems were getting bigger and bigger. We also decided that this was the time to do a 64-bit port. And there's a number of different places where software maintenance costs are listed from 40 to 70%. So if you're already spending time not doing new work, you might as well do some new work, right? One of the things that you have to answer is, exactly what can you use? And there's plenty of links on the internet. I listed a few of them. They certainly are not the only reason for which you can pick and choose as far as what goes into your code base. I've had a number of people talk about they can't use a particular feature in their C++ code base, or they don't care about a particular feature. And I've asked them, well, are they dependent on third-party libraries? And they've said yes. So their third-party libraries haven't updated, so they're in a hole. Likewise, in our particular real-time simulation, we're running in kernel mode. And our vendor supports officially one compiler. So that means that even if we wanted to be portable to other platforms, those aren't making money for us right now. So not only is it limited to what's in the compiler, but also what's limited on the operating system. I've also talked to people who've said, we don't want to be in the business of supporting the compiler. We've picked an operating system. That operating system comes with a compiler. That's it. So you get whatever you get. They're not going to support any user updating the compiler on their own on their operating system. So that plays into it. Just a few months ago, Clang and LLVM switched their build system. So you could finally start using some C++11 in developing Clang and LLVM. And typical set of comments there about what you can use. They've actually been talking about, thinking about maybe striking to 2012 and going to 2013. Officially, they were saying they want to support the compilers that were, the last two versions of the compilers that were available when they did their release. So there's, whether they moved from 2012 to 2013 is a question. Yeah, how are you going to do it? Brute force here, I mean, you're going to take a bunch of developers, you're going to sit them in a room, you may send them to conferences to learn about C++, and they're going to read the code, they're going to make changes, whatever. As part of that analysis, they may decide that, hey, there are some tools that we could write via Klang's lib tooling. Or they might use some existing tools. And as far as the second one that's listed there, I will point you at Peter back here. I've seen his talks. I have not actually used his product. So if you want to know more about that one, you can talk to Peter.
I didn't pay attention because I was working. Did you actually try it already? Or?
I have not tried it yet. Like I said, I've seen your presentations and I know what it's supposed to do. So unfortunately, I already have a C++11 code base, so I don't know what it's going to do, if anything. I could probably find some code to do something with. All right, so we're going to go through several things with Clang Modernize here. Has anyone used Clang Modernize? One person, two people. Okay. So if you don't know, it does a series of transformations. The first three that are listed here are ones that we used as far as with Clang Modernized. As far as auto pointer, we had maybe one instance of auto pointer in our code base and decided, you know, we already know how to replace that. We don't need a tool to replace that for us. Auto, at the time that we were running Clang Modernize, it wasn't clear whether or not we wanted to actually potentially have lots of changes as far as auto to the code base. So we didn't look at that one. And override was not supported by our compiler, so that's why that one was not used. Okay, so as an outcome of using it, these are some of the results. On Windows, it's certainly 2 years ago, it was very problematic to use. Today, it's a little better. But if you've got a code base, especially that's including Windows.h all over the place, you're probably going to need some other headers. As far as the last two, there's sort of an order of operations here. If you were to go through your code base and remove raw pointers in favor of smart pointers, you may at the same time get rid of any comparisons with 0 or cat null from the C libraries. So if you were to run this on a code base after removing raw pointers and putting in smart pointers, you may not see as many null pointer transformations. The same can be said for the second one. Our code base did not have any move semantics in it. In fact, it was explicitly not movable, which means we had, I think 2, if I recall correctly, instances where this occurred. There is some risk using Clang Modernize, which you can tell by there's a command line option called risk. To date, I've never used the risky option. For each one of those transformations that were listed on the previous slide, you can go to Clang's website and you can see what they mean by a safe transformation, what they mean by a reasonable transformation, what they mean by a risky transformation. There's also that very important final syntax check. So it can do the transformation, it can then do a syntax check and tell you whether or not the transformation was actually good. And we'll see why that's important. So here's a nice little example. We've got a class that pretends to be a container. It's got begin, end, size, subscript operator, nothing too big. And we're going to pretend like Sean Parent's talk didn't happen, and we've got a for loop here. So if you ran this with safe mode, nope, it's not going to do the transformation. You run it with its default setting, it does the transformation, and its transformation is about what you would expect. Everything works as well as it did before. If we make 2 little changes, so here our subscript operator returns the pointer, which is the value type, if we believe the iterator type def, to returning a reference. And we're going to take the address of the result of the subscript operator. As far as the transformation, same exact results. But we get a compilation error now. So this was run with that final syntax check on, and it came back saying, I did a reasonable transformation, and it's no good. And the reason I bring this up, suppose someone decided, well, I'll just throw in that C-style cast that James and Kate said you shouldn't do. And now we get the same results, except we have this nice little runtime error. You might say, well, if I'm doing this on Windows or Linux, I'm probably going to catch that pretty early. Kernel mode, no read-only pages. Who knows what that wrote to? Yeah. Now, this problem was actually complicated because this is what I looked at after the change. My little diff tool nicely highlighted in red the 2 places from before and after. And of course, my eyes went exactly to those 2 places in red. And I said, yeah, seems reasonable to me. I'm going to ignore everything else on the line. So at review time, I probably could have caught this. Instead, it actually went into source control and actually went to integration test, and that's where things blew up. So the comment here about engines are bleeding, engines don't actually bleed, although it is undefined behavior, so. As far as who does your work, so if you're in that brute force mode, you know, you've got your developers who aren't here, aren't learning about C++ necessarily. It might be this common C programmer who relied on the fact that previously any function that was not declared in C was assumed to be an extern int. So the story here goes, lots and lots of code was supplied to us, and giving a warning level of 4, lots and lots of warnings were generated, enough that no one bothered to look at them. So quite conceivably, those type of warnings would have been listed. Instead, code went into integration, runtime exception occurred, and assembly debugging pursued. And as it turned out, it was MSVC given a 0, and there was a divide by 0 somewhere. If you do this with Clang or GCC, you get some really interesting messages back. They'll say, I see printf, but you didn't include standard IO. I see PAL, but you didn't include math.h. And they'll tell you what exact functions they're actually picking, so they actually get the right answer. So here's our other C programmer. He's done some interesting things here. This one, so in C++ 03, this was officially deprecated as far as conversion from string literals to char star. And now for C++ 11, our Annex C actually says that is completely invalid. But of course, for C, you can still do this. And again, kernel mode, no read-only pages. At least there's a warning. All right, so our other C programmer, they've tried. They've got at least a destructor, and we're taking care of getting rid of things. This is R8II from this morning. As it turns out, N was on the order of, I don't know, 50 or so. And so, of course, what did they do? They added 51 and didn't change the destructor. So, again, not a modern C++ issue. It's out there. Okay, so now we got our Java programmer who's used to newing all of their variables. You can laugh. I will say this, the engineer that did this came to me and said, you know, I learned Java and thank you for telling me, and has not made an error like this since. So yeah, those are the engineers that you like. They learn from their mistakes. And when I saw this, just bells were going off, because another part of real-time programming, we don't like to do memory allocations during real-time. Initialization, sure. Real-time loop, no. So this one really stuck out. There were some other issues in here as well that got cleaned up. But at Issaquah, back in February, sitting around the table talking, I brought this up, and Richard just said, oh, well, yeah, you get a copy constructor in there, you can do whatever you want to. Don't do that. Okay. So I don't know where this one came from. We've stuck virtual on an enum. Now, there have been changes to enums in C++ 11. This is not one of them. Clang and G++, they both give an error saying no. Some versions of another compiler accept it absolutely fine. When I looked at it, I said, well, no, virtual can't go on an enum. No, sure. Okay, so I've mentioned kernel mode and doing changes. One of the first things that we did as we were working on the problem from earlier, we were also working on another problem that involved 20 cores. And it was a system where we really had to have diagnostic tools that did not do locking as far as having priority inversions and other things. So I was off doing some lock-free, wait-free data structures, and I would certainly say that is not the place you want to start, especially if you've got those other programmers. As far as boost and other things, again, kernel mode. So there's a lot of boost that we can't use. We've used parts of boost in the past. Very nice implementations. Oh, there's Richard. Had a comment from you earlier. So as part of our update, we actually went through and removed all boost usage. And it was probably limited. It was probably limited to like regex, but things like thread, mutex, they just would never work from boost in our platform. Likewise, file system, path implementations that we've worked with so far actually work fine. Once you start looking at directory iterators and other things, no way. Networking. Anybody know the status of networking in regards to standard? Who isn't the standards committee member? Nobody? Okay. In Chicago, we looked at network byte order and said, it's good to go. It'll be the paper that we can use to form a working paper for a networking technical specification. That working paper was never created. So the network byte order functionality that we looked at in Chicago has now been rolled into the library fundamentals technical specification. That was in Issaquah back in February. In Rapperswil, the library evolution working group decided that the networking technical specification needs some help and looked very hard at approving, pushing along, not sure the exact word because I was not in Rapperswil, a proposal from 7 years ago to move ASIO from Boost into the technical specification. In Champaign-Urbana in November, I'm sure we will be talking about that quite a bit more. Anybody here that doesn't want a standard networking library? Okay, good. It's, for us, kernel mode, own network stack, that one's a little bit problematic for us. Because again, file system doesn't work for us, thread doesn't work for us, mutex doesn't work for us. And so what do we do? You may not be able to tell this, but that picture actually says you can build an airplane too. We match the interfaces for the things that we want, provide our own implementation. So there's a nice clock, pretty simple to do. Talked about thread, mutex. Same interface, it's going to work completely with unique lock guard, no problem. And I did a search of our code base a little while ago. We've actually evidently removed all usages of mutex. Not intended, but a nice side effect. Okay, so I mentioned earlier that we have this explicit problem with the old code base where we had lots of things that were non-copyable. And you would see things like a vector of pointers. So you get an allocation for the vector, you get another allocation for each one of the elements within. Yeah, not very nice. Yeah, so there's the example. Probably read a configuration file, probably allocated a bunch of different foods. And of course, the problem here is that you then have to do the explicit traversal to delete all of them. So one thing that we could do, smart pointer. No big deal there. Now there was a small problem that Stefan all the way saw with C++11. we had make shared but not make unique. So for C++ 14, we now have make unique. And so the real difference between these two is where we're pushing back here, we have mentioned foo twice, whereas there, we just mentioned it once. But at this point, we still have pointers and pointers. Of course, we went through and made a whole bunch of things movable. And now we've gone to value semantics. I will say this. Looking at this, we know foos are going into that vector. Now, foos are still going into the vector. One of my colleagues who teaches C++ isn't quite a big fan of in place yet. He'll come around. Okay, one of the other things from Wrapper's Will, a number of people concerned with embedded applications present and decided that they needed to talk a little more about how C++ should be used in embedded applications. And there's a mailing list where they've been talking about a number of issues. We've seen some of them. There's belief that we can add a no return attribute to main with no problem as far as the way the standard is currently written. And what they were looking at there is any global objects that would have had destructors, they want all that code gone. So we're talking about things with very small footprints, 16 kilobytes. In these particular cases, we're talking about a system that the only way to restart it is a power cycle. So there is no return from main. They were also thinking that there needs to be some sort of early initialization function, so before global object constructors are ever run. And I believe the belief here is that we're looking at pre-allocating memory that could be used with allocators for any subsequent object that gets created. And then, of course, the last one is there's been talk of an exception light, of a standard library, potentially without exceptions. That would be a very big change, I believe. And I probably have talked very quickly, to the point where I'm not even halfway through.
You get lots of questions.
So I will ask for questions. I have one over here, and I have one there. You wanna...
So you mentioned that you went through and made a lot of objects movable so
Yes.
that you could stick them in different containers. What issues did you have making those objects movable? I think one that comes to mind is probably other objects referring to those objects. Was that kind of a rabbit hole of an exercise, or did you find some easy ways to do that?
Radical. I wouldn't say radical. Given that a lot of the code base was in Fortran, we weren't seeing a lot of people actually referencing back to anything that we were making movable. So we probably did not have the examples that would fit your type of code base for me to be able to answer that question. But certainly, as I said earlier, there wasn't a tool that would make things movable. We did go through every single place where we were looking at allocating things on the heap and making them movable. I'll also say this. In looking at them to make them movable, we were saying, there's a lot of state being contained in these things that isn't needed. It was a state that was at construction time that never is used again. So not only did we make things movable, we made things smaller at the same time. There's a question over here.
The stuff on the previous slide, is this stuff that's being talked about? Or
Talked about.
It's not even on the horizon yet.
There is no official study group for embedded related to C++. There might be if there's enough interest or if there's enough of these type of topics that can be shown that people want to work on. So the question was, repeat it one more time. Is this being worked on?
Yeah, what's the state of this?
Right.
I'm not embedded, but I'm interested in the early initialization function.
Next question.
Well, in fact, I was going to ask about the early initialization function as well. Is that something that can be solved by a global constructor with an attribute on it? Or what exactly do you mean by early initialization?
So the C runtime obviously starts up first and calls all the global constructors for all the C++ objects in global. They're talking about something even before then. So that's not really a C++ thing as far as part of the library or anything else. It's more just the way that the compiler would work. I've seen, I think, maybe one reference to this, so I have not been involved in any discussions on that. But it may be coming as far as...
Something nearabouts to where static gets initialized?
Has anyone seen Scott Meyer's talk from the B conference? He has a very nice talk where he goes through the different phases of global object initialization. And so for your particular case, so it would be after probably the zero initialization section initialization. It would be after any aggregate initialization, my guess, and then before the dynamic initialization. Yes, Peter?
I have a question. Did you try using const expr and variable templates to improve the initialization, let's say at compile time?
Let's see here. Yeah, so const expr, no except, variadic, all not on this list. Our compiler doesn't support it at this time. So that's a case where our real-time operating system says this compiler, and that compiler's limitations are we don't have context or we don't have variables.
Maybe you should replace that.
So like I've mentioned several times that, you know, real-time, no read-only memory pages, no const expr, no other features. Certainly a number of issues go away if we would change the real-time system, but then we might have other ones to address. So we're constantly looking at that, and I left this out of the slides. That's not a smart pointer, automatic garbage collection if you want, as far as the memory is being pointed to. If you happen to have shared objects that are loaded, and those shared objects get unloaded on a different system thread than your process was running on, you don't want automatic garbage collection. So that would be another type of issue that we've seen that leads us to believe that maybe a different real-time operating system would work best for us. So, plenty of additional time, otherwise. I know you said that you were looking at these type of issues.
Yeah, so my question, one of the things, you talked about modernizing your code base at Flight Safety. I was wondering, how you guys dealt with educating your other developers at the company, bringing them up to speed on all this, new, all
Sure.
the stuff from C++.
So those immediately that I work with, obviously on a daily basis, we're talking about C++ 11 and 14. For the other groups, we've done now a total of 5 simulators. So we still really haven't gotten all of the hundreds of engineers seeing C++ 11. For those that are more actively developing in C++, they within their own groups are having discussions. We cross-pollinate sometimes, get in there and give them pointers. Likewise, we have a system where I can subscribe to every single check-in, so I'm looking at every CPP file just about, and that's where most of those examples came from. Oh, it's virtual on email.
Thank you.
There was another question.
You kind of half answered it just now.
Okay.
I was wondering, when you say the code base, how big of a code base are you talking about, and what ways are you partitioning it?
So it keeps getting smaller and smaller. I talked about the code bloat and APIs that were easy to misuse. At one point, it was certainly over 1 million lines. I don't have an exact count now. We certainly did repartition because we were at the point where we were sort of just build everything together, redistribute everything, and now we're actually saying, well, we've got things that are more SDK-like that should be built over here. We've got things that are more runtime-like that should be over here. And in doing these particular updates, we said we're going to be more concerned about the SDK because the actual runtime components are probably non-deterministic components and we don't care as much about them. And I can also say this, as part of this update in reviewing the code base, we said there are a certain number of APIs that are older that people might still have code that want to use those, so we recreated them. And we managed to recreate the same bugs. The thread, I said we made something that looked exactly like the standard thread. The old APIs that we had for thread, some of those non-real-time components from the runtime use those. And we were beginning to see some occasional crashes. So you bug it and you find out, oh, here's the problem. And that was in the last major update that we did on it, and that was on the previous major update that we did on it. So now we have this new thread library that matches the standard with well-known semantics. We'll just change everything over to that and go with that. Lots more questions. Microphone.
Did you have any automated tools that helped you identify which of your APIs were unused or any sections of your code that were unused? You said you had some dead code or things that you had thrown out or modernizing.
So you're asking to remember 2 years back. Automated tools, yes and no. There was nothing that went through and said that this isn't being called or this isn't being called. It was more creating pictures of header includes and saying, well, why is that guy got that header? Because he shouldn't be doing anything with this particular class. And so there was a pairing that way. And the rest of it was just searching. Excuse me?
It was pretty much all manual that you did it.
Okay. So we have 2 more questions, 3 more questions. Microphone, please.
So did you guys actually work on Clang Modernize, or have you just been using the features?
Just using it.
Okay.
No, so that particular example, at some point it's like, oh, there's a bug in Clang Modernize. It shouldn't have done that. And when I finally started writing the test case, I said, no, this is definitely a bug that was in our code, not in Clang Modernize. It did exactly what it was supposed to do.
Yep. My other question was, you talked about switching things to pass by value.
Yeah.
I know Clang Modernize has a very specific transformation it does just for constructors. Did you guys go and do a lot more aggressively in other call sites and other use cases? Just used?
No. And conceivably, we could run it again and see what type of transformations it does now, but
it doesn't seem to have got a lot of contributions after the initial kind of burst of development. So
it was officially announced that going native a year ago, going native 2. The examples in the slides of Clang Modernize. There was the first one. And what it did. And the second one. And what it did. Are you looking for something in particular? Oh, okay. And then the final one where we shot ourselves in the foot. I will say this. The example that this came from was one case in probably 20 or 30. So there were a number of objects that had similar code but did not put in this cast. So that made finding this even more difficult because we said we ran Clang Modernize on all these things and only one of them is having a problem. Next question.
Yeah, can you go over a little bit about how you're set up for automated testing and continuous integration during this process of modernizing?
Okay, so continuous integration, think about how we did this. Good question, because from the testing, okay, so from the testing standpoint, earlier they talked about legacy might mean you don't have tests. We certainly did not have tests for a number of things, and we did go through the process of writing tests. We did not have at least a nightly build that was running the tests as well, so it was pretty much up to the engineers at the time running the tests. As far as continuous integration, I would say that for the longest time, we didn't have something that was actually buildable because we had broken quite a few things and trying to put everything back together. That being said, we also weren't actively trying to put a simulator out with this. So it was okay that we had most of the things that were broken. And real-time system requires a compiler to match. For the longest time, we didn't have a real-time system that matched the compiler that we were trying to use. So there were a lot of impediments to actually doing continuous integration.
Did you redoing all this against your tip, or did you have a branch where you were kind of trying to isolate this stuff?
So at the same time that we were changing hardware, changing compilers, changing real-time operating systems, we changed source control. Might as well change everything, right? More questions? Yes, Peter.
Yeah, plenty of questions to ask you. Do you use a static checker like PClint for your code base?
So there are a variety of tools used.
Or there are Coverity or whatever?
We have used Coverity in the past. When our code base was a lot larger, we've not used it since we've been shrinking our code. Some static analysis tools don't recognize that unique pointer will actually free memory, and so you get false positives saying you're probably linking memory. Yep, that's a little hard. The Fortran engineers that are using C++ now, they do use some checkers. I myself, no, not really. Just compiling with 10 or 12 different compilers points out most of the issues. I will say this, I talked about memory allocations. That's more of our issue as far as issues that we see, because you have this real-time system. And if you do the real-time system and then go to the non-real-time system, it works fine. But if you go the other way, it may not work too well. So we see people developing and putting a vector on the stack. And then they put that into the real-time system, and all of a sudden we see a spike in timings because it's doing memory allocations, and that sometimes leads to us rewriting malloc and calloc and other things.
Well, you can always replace the allocator now.
Yes, yes. So yes, we have a bevy of tools that we can use to address that. I will certainly continue to take questions, since I talked fast and ran through all my slides. Give it over again from the beginning. Do it backwards. These slides begin to look better and better as opposed to worse and worse. Yeah, so this talk was supposed to be, for an introductory. I purposely did not go into like SFINI and other things that we had put into our code base as well, because our Fortran engineers aren't doing that. Oh,